Okay, hi. I hope everything is working. I want to do this spontaneously, and of course, everything is broken. I had to log in everywhere. Also, I'm in a new office space, so let me know how the sound is. Could be much better or much worse. Let's see. And yeah, let's get into it. Where is it? We are doing the last, what's it called? Talking Math in Public Animation Generation Collaboration live stream for this year. And the topic is Hilbert curves. Create an animation showing a Hilbert curve filling a square. And I'm not entirely sure what exactly I want to animate about that, but we will see. And yeah, let's get into what a Hilbert curve actually is. So I'm on Wikipedia. I have a new screen, so let me know if the text is way too small in the live stream. So a Hilbert curve is a space-filling curve, and basically this is the idea. You start with this hook, this U shape, and then you replace certain parts by this hook shape, and then you iterate that, and you can do it in 3D. And this is the main idea, and there are two main things you will usually see. The first is like just iterating it, and if we can get to this point, I would be very happy within an hour. If we can get there, that would be good. And what's slightly nicer, but doesn't really tell you how to construct it, is this animation. Oh, how does it work? Make it full screen. So it is a curve, or at least every iteration is a curve, so you can snake your way along it, but of course it doesn't really tell you how to construct it. It's probably that every turn is predetermined by all the other turns made before, but that's not insightful. So maybe we can do that at the end too. And in some way we have to create the points on this Hilbert curve or on the nth iteration. So that will be probably the main part. And I think in the English version of the article, I found an L system, right? A Lindenmayer system. This tells you exactly how to replace it. So you start with an A, and A doesn't mean anything. It's an abstract rule. But then you say you replace A or all A's by this, and you replace all B's by this. And in the end, you draw the curve by doing commands for this plus, minus, and F. So F means draw forward, and plus and minus means turn left, turn right. Maybe just turning, not drawing, just turning, not drawing. And it's related to turtle graphics, which is a really nice intro to coding for beginners. Where you do exactly that. You command a turtle by giving forward steps and turns, and then you can do many things. So my plan is to just copy paste these replacement rules into Cindy.js, and then hopefully have 8-9 iterations of the Hilbert curve very quickly at our hands, and then we can think about animations. So that's the plan. And as I just said, I'm working in Cindy.js. As always, the code will be linked, or the code will be in the GitHub repository that is linked in the description. And yeah, I'm using my animation library, but that's not important for now. We want to have the Hilbert curve first. So where is Wikipedia? Let's put it on the side. We don't need the canvas for now. So let's say we have a function called Hilbert, and let me know if it's too small. I think I can make it larger. Maybe that is looking good on stream. Right, Hilbert. Blah, blah, blah. I don't know how many iterations I want to make. Let's call it n. Do I want to have a special result? Maybe later on. So we have, let's go Hilbert curves. Let's just add it to this thing. And at the start, as we can see, we have just A. A alone doesn't mean anything. So the first iteration should lead us to this U-shaped hook. So let's take a look. We have 1, 2, 3 draw commands, so that would fit those 3 lines. So we have to do 1 iteration to do it. So let's do it. So the start, so the string, we have a string which is just A, and then we replace it a couple of times. So we repeat it n times for our n iterations. And then we say, now I have to look it up, just to make it sure. We have in Cindy.js replace command. I think I want this one. Replace all occurrences of string 2 and string 1 by string. No, I want to have this dictionary. I want to have this one. I want a string, and I want to replace things in the string according to some rules, and I want to do 2 rules at the same time. So the first rule is this. I will just copy paste this. And that should be it. Let's print it to this console, print line string, and then let's see what happens if we do Hilbert 3, let's say. And now we have the first iteration, which should be just the A rule, right? So this is because we start with an A, we should just have the A rule, and the rest we have to believe it because I definitely want to check it until we have drawn it. But that's correct. So, or at least that's implemented. So let's say Hilbert. Let's call it Hilbert strings. Hilbert strings. Just to check how long it would take to make 20, but it's also in an instant, right? So, oh, no, it's not in an instant. It actually takes a hot second. I've overdone it. So let's make 8. Okay, testing things out without thinking too much. Yeah, I broke it. Okay. Let's try to get it to reload. Then we will do, let's clear the cache. Maybe it helps. That was very stupid, but that's okay. Let's just close the browser. Maybe close the web server and let's start again. Right, so we have 3 iterations. So what I was thinking that we will probably want to do this once and then we store the result in an extra file and then we don't have to recalculate it live every time. But I want to do a stress test. So let's see. There's 7 iterations. It's fairly quick enough. 9 iterations. Yeah, it's okay. So let's say that we do the first 6 or something like that. In the end, let's test with 5. Okay. And now it's broken again. I don't know why. I did have, what is this? This is, all right. So I did have problems with Cindy.js not properly loading in the last few days, but okay. So let's test it with 5. So, and instead of printing it, we will store it in our Hilbert string. So Hilbert strings is Hilbert strings string, and we want to do this after the first iteration. So we have now all strings we need for our draw commands. And what I now want to do is I want to take Hilbert strings. So if we go back to the Lindenmeyer system, so F means draw forward, plus means a left turn, minus means a right turn. A and B are ignored during drawing. So A and B are just for the generation of the replacement rules. So we can ignore that, and that means we will delete them. So we take apply Hilbert strings, and then we do the same thing as here. We replace every entry. Can someone tell me why this is yellow? And why I don't want to have code. I don't know why this is yellow, but that's okay. And now we want to replace A and B with empty strings. Right, and if we now print line our Hilbert strings, we should have only draw commands, which are very confusing, but that's okay. Right, so, and at the start, I just want to have abstract steps. So every step is one unit, and then we move, and then in the end, we think about how we have to rescale it and translate it into a right position. So we will start at 0, 0, and just move upwards, and then we scale down. Right, so we have Hilbert strings, Hilbert curves. So this is now a list of curves in the end. So for all Hilbert strings, we do something. We think about how we can turn these strings into points. So first of all, let me look. Can I do this? Can I do this? Right. So what I want to do is I want to go through a string and take the first command, which it represents, and do something with it, and then I want to cut it off and make the string shorter. But Cindy.js is a little bit wishy-washy when it comes to treating strings as arrays, and sometimes it's exactly the same, sometimes it's different, sometimes a string gets turned into an array if you do something to it, so it's not as neat as I want, but I think I don't have to overdo it. So if I do this, I'm getting a string back, I assume. Right. Okay. So for all strings, we say point is we start at 0, 0. And we want to have a direction. Direction is, at the start I want to go upwards, so it's 0, 1. And in the start we want to have a result. The result is our point. We start at 0, 0. And in the end we want to have the result added to our list of curves. And in between we have to think a little bit. Oh, okay. Good, good, good. Then we can go through our string. So for all Hilbert strings, so let's give it a name, string. Our string is let's do a while loop. A little bit dangerous, but that's okay. While the length of the string is larger than 0, we do something. And what we are doing is we take the command. The command is the first element in the string. And in the end we say some byte string. So byte is a function that I defined for arrays, which just cuts off the first element. It naturally in Cindy.js operates on strings, but it will turn the string into a list of individual characters. So in the end we have to sum it to make it a string again. It is probably better to use arrays, lists of individual characters instead of strings to begin with. But I want to think in terms of strings, so I turn it into a string again. So, and that hopefully will work, won't create an endless loop. And we do something with the command. So if the command is f, we do something. And if the command is a minus, we do something. And if it is a plus, and if it is a minus, we do something. And let's make it look a little bit neater. So first of all, if we have an f means draw forward. So we are at a point. Let me quickly check if this is an important message. So if we have an f, give me a second. Give me a second. Okay, we can continue. You're still there, wonderful. We are at the f command, draw forward. So we are at a point and we already added it to our curve. So we move forward. So we say point is point plus our current direction, and then we add the point to our result. Plus signifies a left turn. So we replace our direction by perp of dir. Perp in Cine.js is a 90-degree rotation to the left, perpendicular. And for minus we do the same, but in the other direction, so it gets a minus. And now we should have list of points. Let me double check. With while loops, it's always very dangerous. I always create an infinite loop in some way. So let me double check. For every string we initially generated, we start at 0, 0, and we start upwards, and we start with our starting point in our curve. While the string itself has any length, we do something, and in the end we cut off the first character of the string. So that's good. It should become smaller. And here what we are doing, we take the first one as the command, and for f we move a step and we add a point to the result, and for plus and minus, right. And I also used double equal, with something that I love to do. I only use one equal in the comparison. And in the end, right, so let's see what happens. Print line Hilbert curves. Let's start with 2 iterations. We have many lists, so we have one list and we have a second list. But it looks wrong, right? It looks... Let's start with just one. So... Oh, right. I think because... Oh, Hilbert strings. I think that's because the English... So what I'm very confused about is that here we see that we move to the left consequently without any change. It should be irrelevant what the starting direction is. It just ends up in a rotated version. So we have plus, minus, minus, plus. So let's think about it. We have 4 rotation commands, but of course in the first iteration we only have 2 corners. So the first iteration, the first corner, which is the start of the curve, is also interpreted as a turn. And the end is interpreted as a turn, but the end doesn't really matter for us here. So if we want to, and it turns the main 2 corners in our U shape are right turns. So it is upwards. It's what's indicated here, right? It's globally we go from bottom left to top right. So just to make it sure, we make this here, and let's say print line. Let's do some debugging. So print line, we say make draw step in direction dir, and then we have print line make left turn, make right turn. So right, so what apparently happens, so we have one left turn, 3 draw steps, and another left turn. So I don't know if you can read that in the console output. But that means the minuses had been oh, that's why they are yellow. Right. I copy pasted the strings and it's a different character. It's not a minus, it's a hyphen or whatever it is. So it's interpreted differently. Right. And that looks so much better. We go upwards, we go over, we go down. Fantastic. Right. Yeah. Don't copy paste stuff without. Right. Yeah. So that's why it was yellow. It was a different character which just looked the same as a minus. Right. Let's get rid of those debug messages. They will turn into hell if we do it for bigger things. And now we have something that might look right. Okay, and now we can start thinking about drawing something. So let's say we go into rendering, because that's the part in my package where the rendering happens. And we just say connect Hilbert Curves 1. You just want to look what happens. That looks right. And that looks right. Fantastic. Let's go up to 5. And okay, I now trust that it works. So what I would now do is calculate everything we want for the curves and then move them into a separate file. So let's see whether we can do that. So let's say Hilbert Curves is what we want to call it. Did I saved it somewhere? Where did I save it? I want to call it Hilbert data point CJS. Hilbert data CJS. Right. And here we want to have our output. Right. And what I want to do is I want to pre-process it before saving it. Do I want to pre-process it? Let me So with 5, an iteration of 5, we have 1000 points, 1024, and the next iteration should have 4 times as much. And it already is, yeah. So we want to pre-process everything, calculate it once and then store it and then be done with it, I think. Right. So let's go back to Let's go back to 4 for testing purposes. So let's start making our visuals. We want to have a frame in which everything happens. So frame is, and now I have to think, how did I call it? How did I? Let's go to, do I have rect? Do I have rectangle? What do I want to have? I want to just have a standard rectangle. So our frame is a rectangle at the canvas center. And the width should be, let's start with 20 and 20. Let's see how large it will be. And the 5 is the anchor point. So I always use the numbers of a number pad as the anchor points. So 1 would be the bottom left, and 7 would be the top left, and 5 is the center. And this tells us what this point is of the rectangle. And now let's see how it looks like. We want to connect our frame. Oh, we want to draw it as a polygon. That makes more sense. Right, and that's a nice size. So let's make it black. Black. And now we can try to fill it. So we have frame size 20. Now, if we do our first, so what I want to think about first is the size of our curves. If we do the first step, it goes from here to here, which should be 1/2. So we have to scale it by, so Hilbert Curves is apply Hilbert Curves. So we want to scale it down by 2 to the power of whatever index it is plus 1. So we call it the curve itself and the index. Also, if you are familiar with CindyJS, this is a reasonably new feature I added last year, maybe. That if you have an array function like for all or apply or select or something like that, you can add not only a name for the running variable, you can also add another name, and this is then the running index. So the index goes from 1 to whatever we said, 4 in this case, because the array has 4 elements, and then you can do stuff like that, which is quite nice. So that should work, right? We have to scale it down by 2 for every iteration. And then we have to move it. So we have another apply. So we apply for every point in the curve. So let's move that here. So we have an offset, which we will think about in a second. So this offset, first of all, we want to start in the bottom left. So I should have made that the center, but it doesn't really matter. So we want to have the frame position. Let's factor it out. So we have to have, so we have the frame position plus frame size times -1, that brings us to the bottom left corner, and we only need half of it, I think, to get to the corner. And now we want to make this one move. So if you go back to Wikipedia, do we have a nice, yeah, let's go to the German version. So we are in this grid system, so we have to go one half grid cell inwards. So we go back inwards, and now we have a factor, and the factor is exactly half the step size, and the step size is this here, right? So if we have the first iteration, oh no, we need just the index, right? The index, all right. So this is the step size. The first iteration has step size 1/2. If the side length is 1 whole, then this is half of a whole step, and then we need half of that, right? So it should be this. Oh, it should be this here. Let's see. Again, we draw, we connect Hilbert Curves 1. Right. Oh, I have to scale it up by the frame size, of course. So this is frame size. Right, that looks good, right? And 2 and 3. Right. Now if we make a big pre-processing step and store everything, we are committed to this frame. But I think that's okay for the scope of this video. Right. So it works. Fantastic. All we have to do now is print them out. So print line Hilbert curves. We only get them to, where is it? We only get him to, I think, 3 decimal places at most, but that's okay. And that's the whole array. And now we want to do this, let's say 8 times. And let's say to see that it is actually working. So we make a print line statement here, which gives the index, and we make a print line statement here about the length of the string, so we can see that it is actually working, and then we have to wait a little bit. Let's hope. Okay, the string replacement was quick, and now, well, you see we have to wait. Right, so 40,000 for for the last one maybe. What did we add? 1000 at iteration level 5, right? So 6, 7, 8 is 64. Let's see. But we see it moving down. Maybe this was a dumb idea, but no. That's also why doing these animations as a live stream is dubious at best. I could cut this out if I condensed it into a like 10-minute, 15-minute overview tutorial and do the full video maybe as a bonus, extra, unlisted. Look at that. 100 iterations per second. Which means we have to wait 3 minutes, maybe. Well. I don't want to do anything. I don't want to disturb the computer. So if you have any questions about Cindy.js or hi, welcome to the stream. It's moving along nicely, right? That's okay. It's speeding up. I don't know why. I'm always extraordinary. Oh yeah. Now we have 150. Right. So that's 5 times as long as now. So we have another 5 minutes maybe. Oh Jesus, that's not good. But yeah. Can you explain it again? What exactly? The Hilbert curve or the Lindenmayer system or? So I can try to go to Wikipedia. We can still see it moving, right? So what we're doing is we want to go. Can I make this? Can I? Yes, I can. So what we want to animate something about Hilbert curves, and the idea is you start with this U shape, this hook. Why are you spamming hi in the chat? Curve. Yeah. So this whatever we want to call this shape, and you want to have a space filling curve in the end, which is not really important for our discussion here. And you want to replace it. So you want to replace this part with another of these U hook shape. And here at the top, the corner, you want to replace it too. And here, and you want to do this in the systematic way. And then you connect them. So you want to, if you have a straight piece, you want to have the U, the opening point outwards. Whoops. And if you have the corner piece, you want to have the opening of the U shape point down to the straight parts. So basically what it means, you replace this hook by this Y-shaped mushroom tuning fork, whatever you want to call it. And now you iterate it again, right? So you have this U shape, so you replace it by this tuning fork. And you have this U shape, and you replace it by this tuning fork, and so on. And if you iterate it if you iterate it more and more, you will get a bijection, because it's a curve, right? The limit of this process will be a curve, which is a bijection between r to the 1 and r to the 2. And of course, it's just a pretty thing to look at. And that's what we want to do. And most explanations how to do this has something to do with you take a point along the curve, and for every point, like you parameterize the curve from 0 to 1, and then you write every parameter point in base 4, and then depending on what the digit is, you do something. Basically, the digit in base 4 tells you exactly in which area you are, whether you are in this part, and this part, and this part, or in this part. And if you go down the decimal places, you will go down these iterations, basically. And I always find this very confusing, how to do that. So what I am doing, so here, this stuff. So what I'm doing is I'm using a Lindenmeyer system, which is here, which is doing the same, but it allows us to generate it in order from the start to end. What are the specs of your PC? Oh Jesus, I have no idea. Let me. It's been a while. So I have an AMD Ryzen 7 8-core processor, 32 gigabytes of RAM, because I imagined for software development it's always very good to have more RAM, and RAM is cheap. And a relatively old Radeon RX 580 GPU with 8 gigabyte. I want to replace it soon, especially now that I have bigger screens. So reasonably good for more than enough for software development, but it could be better. So especially if you're doing app development, you don't need too much, because if you're talking about mobile apps. So I'm old, so for me app always means a mobile app, but of course everything is. Did it finally crash? No, it's still moving. Everything is considered an app these days, right? So yeah, and what we're doing now, if you're just turning in, we're doing this Lindenmeyer system, which allows us to generate the points on the curve in order, which is then very easy to draw in the end. But now I decided to make 8 iterations deep, which has apparently 175,000. What is it? 4 to the power of not 10, 11, 8, of course, 9, maybe 262, 65,000. I don't know. A lot of points, so we are waiting here for this to process. So we took this replacement system, we started with an A, and we made these replacement rules to get the draw commands we want to use, and now I'm turning that into very explicit concrete points. And that just takes forever, but that's okay. As I said, I don't want to do anything because otherwise it will kill my PC. But we can try to plan out the animation. Maybe that's okay. So first of all, I want to draw the first iteration. So draw first iteration. Let me think. Can I do that? Is that okay? let's see how bad it will be. And then I want to show how you replace it. So we want to we go back to Wikipedia. I want to show you make this replacement, you make this replacement, you make this replacement, you make this replacement, and then you connect them together to make a single curve. So you make basically replacement 1. Let's be a replacement 1, replacement 2, replacement 3, replacement 4, and when we are doing the first replacement, I also want to fade out the first iteration a little bit. Make first iteration less opaque, more transparent, half transparent, and then we connect and fade out is a good one. Fade out first iteration halfway, fade out first iteration completely, and then we do it again. Maybe then we have 2 iterations, then it looks fine. So let's make more tracks. So my animation package always works with these tracks. So every track you can imagine is a single motion, a single movement. And I'm always using these comments at the end to plan out what those movements should represent. And these movements are generated from track data. The first number is always the duration of the movement, and the second is the pause between this movement and the next one. And by default, I always say a movement has 1 second as a standard length, and then we have, while we are in development in real time, 0.1 seconds as a pause. Okay, so we had our next. So we have the first iteration. So we want to go here. So we have 16. 1, 2, 3, 4, 5, 6, 7. We have 16 replacements to show. Show replacements of next iteration. Let's see if that works the way I imagine it. And now we do this overlapping. So at the first we want to have one replacement after the other, so we can see it. So maybe have no pause between them. That's okay. But one after the other, and then we do the connection, and now we have connect plus fade out second iteration half fade out second iteration completely, and then we have show iteration or jump to iteration 3. Right, now then we do jumps 3, 4, 5, 3, 4, 5, 6, 7, 8, 8, 7, 6, 5, 4. And then we will see where we are. We're already an hour in. It's still processing. That was so stupid by me. But here we are. Let's. Right, I will just start coding these movements, and hopefully it will work out. Right, so what we want to do, let's, or do I already wrote print line, right? Okay. So once we load again, we don't want to do that anymore, and we don't want to do that anymore. That's just for the one that's already running. What we want to do is we want to just draw it as a stroke. So let's make how lazy do I want to be with this? Is there any benefit in drawing it? Okay, maybe the next thought is there any benefit in having the grid? Let's go back to the German version. Is there any benefit in having the grid? I mean, probably. So let's say, okay, grid 1 is oh, that's super annoying, but it's processing anyway. Grid 1, we apply 2, so we go from 0, so we go from 1 to 1, and we create an edge. This edge is frame position plus 0.5 times upwards. Oh yeah, that will take a while. Frame position 0.5 upwards times frame size. Hoppala. Where is it? Right. Comma, and we go downward. That's the vertical part. And this we apply it to an array of length 1, but I want to copy paste the code to the next grid. And so this is the vertical line, and that's the horizontal line. And we want to fade it in. Do I want to fade it in? I'm not convinced that the grid is a good idea, because then we have to make the transition not only on the curve but also on the grid. If you make the replacement and then refine the grid, why not? Why not? So this is the first grid. All right, that's. I'm missing something completely. Let me. I'm overthinking again, as always. Let's make it. let's just make it like that. And then the next grid, we want to have the refinement. So the refinement is, we have this one, so we want to have this and this. So we go, half a step to the left and up. Is that right? We go half a step to the left and up, half a step to the left and up, half a step to the right. Right, that sounds good. And here we do the same. Of course, no testing because my stupid code is still running in the background, but that's also okay. So these are the new lines, so we can fade them in. So we just, then let's just do that. So we take, let's say, what is grid? Grid is a collection of lines. So for all grid 1, they should be under the frame border, I guess. Under the frame border. So we make the frame 2 pixels wide. For all grid 1, we draw them. We make them like 0.5 and the size is 1. And the alpha value, now we're coming to the animations. The alpha value, we want to just fade them in. So we say T1. T1 is the progress of the first movement. So while the time moves through time, this first movement will have its progress run from 0 to 1. And this is exactly what this variable gives, and the alpha value is just a transparency. So that's grid 1 and in movement 1. And we also want to have the first curve. So we say Hilbert, so we draw, we connect Hilbert curves 1, and we do the same thing, but the color should be, let's say, blue. Hopefully I defined it somewhere. Yeah, so blue, we have some sort of blue here. And right, that's the first Hilbert curve, and now we want to have the replacement. The replacement is, we want to connect from the second curve, we want to connect the first 4 entries. And we want to let's make them red. And this should happen during T2. And during T2, we also want to fade out the first one a little bit. So minus, usually for most animations, I'm using easing functions so that you have this more physical, smoother transition from start to end. But with fade-ins and fade-outs, it's often not necessarily worth it. And since we can't test anything right now, this is a catastrophe, but that's okay. All right, so we want to connect those. Then we connect 5 to 8 in the next one. That sounds reasonable, right? So 9 to 12 and 13 to 16. Then we should have all those individual hooks in level 2. And then in T5, in movement 5, that's 2, 3, 4, 2, 3, 4, yeah. And in 6, we connect the endpoints. So first of all, we fade this one out completely in T6, and we make in T6, what are we doing? We connect, let's draw, with only 2 entries, it's a little bit. So we make 4, 5. We draw the 4, 5 edge, the 8, 9 edge, and the 12, 13 edge. That should work out. And right, now we are here. Show replacement, so draw first iteration plus grid 1. Show grid 2 plus show replacements of next iteration. No, let's make that a separate movement. So let's move our plan down a bit. So we show the grid. That can be much quicker. And then we show the grid to indicate that we are thinking about the next level. So let's do this here again. They should be behind the frame just to make it a little bit cleaner. And T7 it is. And right. Then we can do the replacement. So we have 16 replacements. So what I want to do is, in my animation package, I have something which I call a ladder. A ladder is a function which subdivides the progress of one movement into k parts, such that all of them have the same length and such that they overlap a little bit. So ladder is it called ladder? Ladder, just ladder. And do I want to have the yeah, it probably will work. So this is movement 8, we said, right? T8, so let's go down to 8. We have 16 new individual little hooks, and we have what's the last one called? The last one is called separation. So if we give it a 1, those sub movements will be one after the other, and if we give it a 0, they will happen at the same time. And usually 0.7 looks nice. So let's see. And now we want to connect. So first of all, we want to fade this out here, right? So so let me quickly wrap this a little bit, because this is the construction of the second level. So if T8 hasn't started yet, we just use this, and if it has started, we just connect the whole thing. Because then we can fade it out, and where the individual parts overlap, there won't be this weird transparency double effect. 0.5. Let's make T8 3 iterations long, 3 seconds long. And here we are. We connect. Do I want to make a for loop? Probably. For all. We have 16 things. And we want to connect. We do the same as before, right? So that shouldn't be too hard. So we connect. We make the same thing as here. But we take the third curve and we go from 1 to 4. So we start at, we end at 4 times our running index. So we end at 4, 8, 12, 16 and so on. And then we start at, you don't need to have parentheses here with the double point to create a range, but I always prefer it. So something like this. So we start, go to the end point of the previous one and add 1. So if we are at the beginning, we go from 1 to 4. If our running variable is 2, we go from 9. If it is 2, we go from 5 to 8. That sounds good. And we say green and alpha, and here is now where this ladder function is quite nice. We can just say ladder do step without parentheses, I think. And then it just gives the next of this overlapping progress intervals. It's very weird, but it works out nice. And then we do the same again. We connect and fade out second iteration completely. So 9, we fade out completely. And then we are doing this here a couple of times. So if we have 16 individual tiles we just placed, we have 15 gaps. And for those 15 gaps, we draw these connecting lines. So that is this one here, right? So this is if we start, you have to have the end point. So it's this, if we start, it's 4, and we go to one more. So it goes from 4 to 5, from 8 to 9, from 12 to 13, that looks good. And again, we make it green, and it simultaneously, that's good enough here at that point. My typing speed is fast, yes, but I'm also using VS Code shortcuts. So if you are on a line and you press Control C, you copy paste the whole line and then you can duplicate it. And of course you have multi-cursors. So if you, at least on Windows, if I press Control Alt and down, I get multiple cursors. So there are many tricks where you can write faster. It's often just variations of copy pasting things. Now we should have the third level. I'm not too convinced about green. Let's make green a little bit darker. And then we are doing, you can and should probably use VS Code for big projects. At least you should use an IDE. It has, like, I'm not using it that well, but it has Git integration. It has many cool features. So for example, I have a plugin called To-Do Tree. Let's say I want to finish whatever I'm doing here, so I can write a comment which just says to do finish the animation, and then it will highlight it as a to-do, and then if you go to the plugin, it will show me all the to-dos I have in my project, and there are many good plugins. It has language support and special features for all sorts of programming languages, so it's very handy to have such an IDE. Highly recommended. Right, and now we want to switch to the other operations. So now the problem always is that the only problem is that my animation setup, my package relies on this movement structure with the progress variables, which makes it rather inconvenient to just switch things in Cinderella. So like switch the state, like jump from what we're doing here, jump from one iteration to the next. So first of all, let me quickly. So this is 4, 5, 6, 7, 8. Which makes it hard to jump to things. In Cinderella Classic, the desktop application, you have a function called trigger, which is the same as if, but it is only triggered once if the condition you give it switches from false to true. So that would be nice to have here. It doesn't exist yet in Cindy.js. So I always have to think about how to do it. So let's make it very explicit. If T1, if T10 started, so first of all we have to get rid of Hilbert Curve 3. So maybe T9 is also a nice place to fade out the grid, because we don't need it anymore. So let's fade out the grid here. Now we want to get rid of those at the same time, right? So if T10 hasn't started, oh that's not good, hasn't started, so if T10 has not started, we do our construction thing. So if it has started, we do, I have no idea what Haskell is, a programming language that I have no idea about. If 10 is started, let's make it here. So what I want to do is I want to make the next iteration, and then I think I will just cycle through the colors. I want to make the next one. If T10 has started, I want to do that. But only if the next movement is still at 0. Else, I want to do that. I want to show iteration number 5. But only if T12 hasn't started, because T12 is iteration 6, right? Again, you probably want to have some cleverer thing to do. Next, we want to make the next iteration, but only if this hasn't started. Else, this is so stupid, but that's okay. Green, red, right? And then we can if T14 hasn't started, because T14 is iteration 8, we are making iteration 7. I think I will, I'm overlaying everything right now, but we will see that. Give me a second, I get a phone call again. That's... Okay, let's see what happens. We are getting close here. So as I said, I'm probably overlaying everything, but we will see. I'm much too long into this live stream to think properly. 1.5 hours, that's not good. Maybe I will cut it down for the talking math in public thing. But I did all the coding, right? So let's see. In the chat, my profession. I don't know what my job title is. I always in English, I always call it. What do I call it in English? A learning technology officer. I'm working at the University of Applied Sciences here in Munich, and my job is to create stuff for the lecturers. So teaching material, but always technology focused. So helping with lecture videos, creating online courses, doing interactive visualizations, creating educational software in the broadest sense, stuff like that. Yeah. And I mean, technically, I'm I'm also a YouTuber. I recently saw that my ad revenue surpassed 70 euros. So that is the first time that YouTube will pay me money in next week or something like that. So yeah, I'm also making 70 euros per 18 months on YouTube as a profession. So while this here is now chugging along, now this will go fast, right? You remember that. If it started again, I will kill it. Then we just had bad luck, and I will do something different. So let's quickly go through the logic here. If T10 hasn't started, we are doing our whatever we do with iteration number 3. If it has started, we're not doing that. So we're doing this, but this is only working while 11 hasn't started. So if 10 has started, we are drawing the 4th curve, but only if T11 hasn't started. If T11 hasn't started, okay, I think we might actually see the correct thing, and we only have a few seconds left for my big, dumb, stupid pre-processing script. Fantastic. So it still took me 90 minutes to make this very, very simple animation, but at least we could parallelize a little bit. So 1.7 megabyte. Isn't that nice? So pasting. Keep waiting. Oh yeah, that's. Oh, okay. Here we have now. Keep waiting. So I pasted all the pre-processed stuff here into my file. And now I just want to add a semicolon at the end. Yeah, doing 8 iterations was really stupid, but at least you learn something. Don't do it like me. Jeez. Let's keep waiting. Let's keep... Maybe we have to do it again, but then I will only do 5 iterations if this is now... Just want to make a semicolon and save. I don't. Something happened? Right. So I will probably stop the stream in a second and make a pre-recorded finish edit where we... Jesus. And and not live streamed finish of this, because this is now right. Yeah, let's oh, maybe not. So let's see. Team up animations. Let's just drag it in and see whether anything is still right. So let's try pasting it one more time. And let's see what happens, and then I will just finish the animation off screen, and I will upload a pre-recorded supercut, maybe. Keep waiting. Or just add it to the end of the live stream recording. I think that makes more sense. Yeah, it's still... Right. Maybe I can save it real quick. And then we don't need it anymore. That would be good. Just want to save. Let's wait for one more iteration, and if it doesn't save, then we will just quit. And I will finish this off screen. Okay. It was nice to have you as visitors here in my stream. I was very stupid. I didn't prepare. I didn't test. Usually I test these things and just pretend that I'm doing it live. So yeah, the live stream will be in the playlist. So let's go back. The live stream will be in the team up playlist, and I will add another video where maybe it's a supercut, edited down version of everything, plus the finished animation over the next few videos. The wallpaper, you want to see my wallpaper? It's a screenshot from The Wind Rises by Hayao Miyazaki. Here it is. All right, that's a failed live stream, but that's okay. No, the live stream was a success, I guess, but producing the animation was a failure. So you can look forward to a hopefully shorter than 90-minute video uploaded within the next few days. And yeah, the Talking Math in Public animation generation collaboration will continue next year, as far as I'm aware. Maybe I will do a few other live streams for my regular videos if I have time to think about them. But for now, that's the end of this live stream. It was nice to have you here, and goodbye, and until next time.